Hi friends, see in part 2 rotatory motion we discussed about moment of inertia of uniform ring, about an axis passing through the center perpendicular to the plane, and also about diameter and also about one end. Let us discuss today in part 3, that is last part of rotatory motion, that is last part 3. In this we will be discussing today about moment of inertia of a uniform disc. Okay, let us discuss about a moment of inertia of a uniform disc, thin disc, about an axis passing through the center and perpendicular to the plane. So this is the axis, the disc is rotating like this, uniform thin disc it is. So how to get for this one moment of inertia? Moment of inertia of the disc. So how we will get the disc is, what I will do is I will make it into small rings. So disc is nothing but what? It is a small rings. See, when you cut small rings, these such rings, when you pile up, you will get a disc. So let the disc original radius be capital R, okay, and the disc radius be x and the thickness be dx. Let the thickness of the strip of the small consider disc, which is nothing but a ring. So when you take a small rings and pile up, it becomes a disc. So a disc యొక్క radius x అనుకుందాం, దాని యొక్క thickness dx అనుకుందాం. Now how to get moment of inertia of this disc? As I told you, disc is completely spread with area. So let us consider sigma. Sigma is the density per unit area. That means mass per unit area. What is the area of the disc? Pi r square. Pi r square, equation 1. So here, what is sigma here? In before case you are considered as lambda, linear density. Now it is areal density. That is sigma is equal to mass, capital M, mass of the entire disc per unit area, where r is the radius of the disc. Now what I will do for this small strip, how will get density, areal density? Mass of that strip into area. How to get the area? This one, area is nothing but what? So let the mass be around dm. Let the mass be dm. So mass by area. Area of the strip allows the perimeter into thickness. That is 2 pi x into dx, where dx is the thickness of the strip. So here the areal density of the small strip is nothing but what? Mass per unit area. Area means perimeter into thickness. So therefore ఇక్కడ నుంచి ఏమవుతుంది మనకి sigma into 2 pi x dx is nothing but dm, mass of the small strip. So ilanti strips, these type of strips will be having so many inside a disc. So to get the total moment of inertia about an axis passing the center perpendicular to the plane, you have to integrate it. So first of all, what is the moment of the small disc inertia? Mass dm into square of the distance. How much distance it is? X square. Mass of the disc, okay, into square. Therefore, moment of inertia of the small strip is equal to mass dm. What is dm here? You can see sigma 2 pi x dx into x square. This is ఏంటిది? ఒక స్ట్రిప్ ఇది, కానీ మొత్తం నాకు ఇక్కడ నుంచి సెంటర్ నుంచి మొత్తం whole radius కావాలి. So how you will get? I will get by integrating from 0 to I left side and here 0 to capital R to get the total moment of inertia of the entire disc. So therefore I is equal to constants and by this end, so constant sigma 2 pi is a constant, and what is left over inside? X into x cube dx integration 0 to capital R. Now if you integrate this one, I is equal to sigma 2 pi, what is x power n dn integral? X power n plus 1 by n plus 1. So this will get it as x power 4 by 4, and what are the limits? 0 to r. So this is nothing but what? Sigma 2 pi upper limit minus lower limit integration process, r power 4 by 4 minus lower limit in the function by 4. So, this is 0. So, what is the final one? I is equal to sigma 2 pi. This is r by 4. Now, this one I will write it as in this notation. 2 1s are 2 2s are cancel. You will get it as sigma pi r power 4. I can write r square into r square by 2. Now, see the equation 1 here. What is equation 1? Sigma into pi r square. That is entire areal density of the disk, which is capital M. So, sigma into pi r square. Sigma into pi r square. Then what I can write? I can write as capital M. So, if I write it capital M, this entire one, then m r square by 2. So, finally, what is the moment of inertia of the uniform disk passing the center perpendicular to the plane? Integration method, derivation. That is, I is equal to m r square by 2. In intermediate public examination, this is very important. It is a 4 marks derivations. Okay. So, if they ask you what is the moment of inertia of a uniform disk passing the center and perpendicular to the plane. So, the moment of inertia is m r square by 2. R is the radius of the disk. M is total mass of the disk. Please copy it. Very important. And this you will be using in numericals. Okay. Right. Now, let us go to the next version of the disk. The same disk. Next version. Next version means already see you have discussed in uniform ring. So, what are the other questions in this one? For same disk, they may be asking about one end. Same disk, they will be asking about one end. Okay, already this is the main axis. Radius is already R. This is the main axis, y dash. Suppose if they ask you what is the moment of inertia of the disk about one end, అంటే ఇదే డిస్క్ ని one end అడిగినప్పుడు you can apply parallax theorem again. So what is parallax theorem? So parallel axis theorem we already discussed in last class in part 2. That is I is equal to Ig plus mr square. Just apply the formula. Moment of inertia is equal to Ig means about passing the center. Just now derived. That is mr square by 2 plus mr square. So if you take LCM, I is equal to 2 mr square plus mr square. 3 mr square by 2. So this is the moment of inertia of the thin uniform disk about one end. Other thing, if they ask you about diameter, see, if they ask you about diameter, also you can calculate 3 questions. Okay, so each will be having 3 types in this one. In uniform ring also discuss about 3 questions. So in a question, the same thing, they ask you about diameter. Diameter, this is x-axis, this is y-axis. 2 diameters, let it be ID about diameter, and this is by ID because both the diameters are same. Let the moment of inertia about x-axis ID, y-axis ID. So how to get it? Let another axis which is z-axis, this one passing the center, z dash. Now to get about diameter you can use now perpendicular theorem. Perpendicular theorem em cheptundi? See here. From perpendicular theorem, Iz is equal to Ix plus Iy. So therefore Iz already manaku telusu. Entadi? Mr square by 2 passing to the center perpendicular to the plane is equal to Ix, Id and also Iy, Id. So Id plus Id, that is 2 Id. So moment of inertia about the diameter is given by, I'll write it here, mr square by 4. So for a uniform thin disk, moment of inertia about diameter is taken by using perpendicular theorem. That is Iz is equal to Ix plus Iy. Iz manaki the center, passing center. Already మనం derivation చేసాం. mr square by 2. Therefore mr square by 4. Clear all of you? Please note down. Right. Now let us go to the next one after completing disk. Very important one. That is See, after this one, I think in the intermediate examination nowadays, some derivations are not asking regularly. The main derivations are uniform disk, okay, thin rod about end, about center they are asking. Remaining part they have removed, I think, I suppose. So therefore, andike what I will do is, remaining bodies like hollow cylinder, solid cylinder, avanni kuda, just I will give the formula because derivations are removed nowadays. So next item, that is, we will go for cylinder. Cylinder. Cylinder now, let us go first. Solid cylinder. Moment of inertia. Solid cylinder. So you can see this is a cylinder. This is a cylinder. Suppose this is the main axis. You can take x-axis dash. Now the cylinder is rotating in this fashion, like this. Cylinder is rotating like this. Okay, like this you can see. Like this it is rotating. This is the axis. This is the axis. Cylinder is rotating like this. Okay. So when the cylinder is rotating, what is the cylinder? Solid cylinder. When you cut the cylinder, you can see like this with a knife. Small discs are formed. So solid cylinder is nothing but, see, solid cylinder is nothing but a disc. Small disc, when you pile up, you will get a solid cylinder. So disc already you have derived. What is the disc formula? Moment of inertia. Moment of inertia of disc is nothing but mr square by 2. About the center passing to the center and perpendicular to the plane. About this axis, mr square by 2. Now he is asking about what? Solid cylinder. And a solid cylinder moment of inertia about this axis is nothing but the moment of inertia of a disc. Moment of inertia of a disc value edaithe undo, this is nothing but cylinder. So solid cylinder moment of inertia about this axis is also equal to the moment of inertia of a disc. Now in the same way you may ask another question. See, suppose the axis is passing in this way, y dash. Same solid cylinder, if the axis is passing like this, elant axis is this axis is nothing but passing to the center perpendicular to the length. That means it is going towards the diameter. Appudu enta avutundi? Moment of inertia of this axis passing the center perpendicular to length enta avutundante, already in the thin rod I have derived one derivation beginning, that is ml square by 12. Therefore ml square by 12 passing the center perpendicular to the length. This is the length of the rod and this is radius r. So plus it is cutting the diameter. Just now derived diameter. What is diameter? mr square by 4. So mr square by 4. So what is the total moment of inertia of the cylinder about an axis passing through the center perpendicular to the length? It is given by ml square by 12 plus mr square by 4. Very, very important in the examination. ml square by 12 plus mr square by 4. Please copy it. So this is about solid cylinder. Okay. Now I will go to the next item. Hollow cylinder. Solid cylinder అయిపోయింది కదా. Next I will go with hollow cylinder. See, in a hollow cylinder what happens is, hollow cylinder. జాగ్రత్తగా గమనించండి. చూడండి. Hollow cylinder అంటే ఏంటి యాక్చువల్గా టెక్నికల్గా ఇఫ్ యూ అబ్జర్వ్ మ్యాథమెటికల్లీ సిఎఫ్. See, hollow cylinder అంటే లోపల ఏం మెటీరియల్ ఉండదు. See, when you take a cylinder, inside completely it is nothing. So, when you cut the cylinder, what is nothing but a ring. Therefore, moment of inertia of a hollow cylinder, hollow, nothing is there inside. About suppose this axis if we take, this is nothing but which is equal to the moment of inertia of a ring. Uniform ring moment of inertia ఎంత వచ్చింది మనకి? mr square. Ring moment of inertia ఎంత వచ్చింది? mr square. So the moment of inertia of a uniform ring about this axis is equal to same as the moment of inertia of a hollow cylinder. That is simply mr square. Suppose if you ask you like this about an axis y dash, hollow cylinder, an axis perpendicular to the length and for example, if I ask you about the length, then what you have to do? See, moment of inertia is given by about length means passing through the length already you have derived ml square by 12. ml square by 12, and this is axis cutting the diameter again. Cutting the diameter. Therefore, whatever value you got, this one mr square, that is mr square by 2, because two diameters are same, id plus id is equal to mr square. So mr square by 2. So this is the moment of inertia of a hollow cylinder about an axis perpendicular to the length of the cylinder, that is ml square by 12 plus mr square by 2. Clear? Copy it. 1, 2, 3. Right. In the same way, next one, sphere. Next one, sphere. So all these are very, very important in moment of inertia. Next is solid sphere. Solid sphere. ఇది కూడా derivations examination అడగట్లేదు, directly you can remember the formula. Suppose this is a solid sphere of radius capital R. For solid sphere, moment of inertia, okay, is given by simply 2 by 5 mr square. 2 by 5 mr square. M is total mass of the sphere, solid. R is the radius of the sphere. In the same way, suppose if they ask you hollow sphere. If they ask you hollow, that means no material. Sphere లోపల material ఏం లేదు. For hollow sphere, it is just like a shell. లోపలంతా ఖాళీ ఉంటుంది hollow sphere. So for that one, it is taken as 2 by 3 mr square. Solid sphere of radius r 2 by 5 mr square. Hollow sphere 2/3 mr square. Okay. Right. Now let us go to the, I think, last one, cone. Moment of inertia of the cone. Last one, I think. Okay. Right. Now let us go for cone. In cone, if you observe carefully, see, let us take first one, solid cone. So many times you will be eating ice creams, isn't it? Suppose this is a cone. Solid cone, that means completely material is there inside, solid. That means mass is mainly concentrated in the center for solid cone. So this is the axis, y dash. This is the radius. Now for solid cone, if you make small pieces, it is nothing but disc, but decreasing disc. Suppose if I take a small disc here, చిన్న disc తీసుకున్నాను ఇక్కడ. See here? It is disc, solid కదా ఇదంతానే. In solid cone, if you take, it's a disc. Disc, you know, no? What is the disc moment of inertia? mr square by 2. But it is decreasing order, you can see. Gradually it is decreasing. See? And the main mass, it will be at the center. Suppose this is the height. Suppose this is the height of the cone and this is the axis rotation. The cone is rotating in this fashion. If this is height, the main mass is concentrated at the center, not on the surface, because it's solid. Suppose this is capital R and this is small r, and here x is equal to 0. Okay? From x is equal to 0 to x is equal to h. X is equal to 0 to x is equal to h. For example, you can see a small point here. Let this distance be x. Let us consider a small disc, solid disc, at a distance x from the above point. So by doing some mathematical relation, you can derive this one. That is, mathematical relation enti? This one, see, small r by capital R. Okay, small r by capital R is equal to small x by capital H. So you can use these relations here. Small r by capital R is equal to x by h. And using these relations and the small elemental disk, and by integrating within the limits from around 0 to whatever value h, okay, you can get this one. But in the derivation already just now I told you in the examination are not giving, just you can remember the formula. For solid cone, moment of inertia, solid cone is given by 3 by 10 mr square, where m is the total mass of the cone, solid cone, r is the radius of the cone. Okay, so for solid cone, moment of inertia, because total mass is cone at the center, therefore for solid cone the moment of inertia is taken as 3 by 10 mr square. In the same way, you may ask for hollow cone. Hollow cone and enti, what is hollow cone? Inside material is not there. On the surface the maximum mass will be there. Okay, on the surface maximum mass will be there. In the same way, if you cut the hollow cone, it is nothing but a ring, and it is in decreasing order again. I think the hollow cone chusnattuga, suppose this is a cone. For hollow cone, if you observe carefully, this is the radius, and if you cut any small piece, and this is nothing but ring in decreasing order again. And here material is not at the center on the surface. Let this total distance be x. So material maximum will be on the surface and at x is equal to 0 to here. It is starting but x is equal to 0. Suppose the length L anukunnam, capital L. X is equal to 0 to x is equal to L. So you have taken a small elemental length of uniform ring. What is uniform ring? Moment of inertia about this axis, mr square, mass into radius, dm mass. Let this mass be dm. So dm into r square. Adhe disk aithe mr square by 2 ante dm into r square by 2. mr square by 2 kada, and integrating again. You got 3 by 10 mr square. Ikkada hollow kabatti lopala material bite untadi surface meeda. So here also you can take some relation. Suppose the small disk is placed, taken from x, from this point, total length be L, then relation goes like this again, same. Small r by capital R is equal to x by L, same relation. Small r mathematically by capital R is equal to x by total L, x by total L. Taking this relation and putting here and integrating within the limits from 0 to L. The integration limits are 0 to h, because total mass is contained at the center, solid kabatti. Hollow kabatti on the surface. Here 0 to L, here 0 to h. So here you will be getting how much value? Moment of inertia, right? Shall I write here? I'll write here. Moment of inertia is given by, I think, simply mr square by 2. Okay? Mr square by 2. So this is the moment of inertia of a what? Hollow cone. Solid cone is 3 by 10 mr square. Hollow cone is mr square by 2. M is the total mass of the cone. R is the radius of the cone. Clear? Now these are the main moment of inertia in the examination they will be asking. Okay? So till now we have discussed moment of inertia of a uniform ring, mr square, about one end, 2 mr square, about diameter, mr square by 2. In the same fashion, uniform disc, mr square by 2, about one end, how much? Mr square plus mr square by 2 plus 3 by 2 mr square. About diameter, mr square by 4. Okay? And after that, you have discussed about cylinder, solid cylinder, about an axis equivalent to disc, mr square by 2. About length, mr square by 12, plus about diameter, mr square by 4. Okay? So cylinder అయిపోయిన తర్వాత మళ్ళీ sphere discuss చేయాలి. Solid sphere 2 by 5 mr square, hollow sphere 2/3 mr square, solid cone 3 by 10 mr square, hollow cone mr square by 2. So these are very, very important regarding examination. Okay? Now we will go to the last topic in this one to end up this chapter, that is rotatory motion, that is angular momentum torque. Okay? angular momentum and torque. Let us discuss the last points to end up this chapter. See here, and this is the last part. I think hardly some 15 minutes, 20 minutes, chapter will be over, and then we can go for the next chapter, I think oscillations. Right. Now, in this last point, we will be discussing some points regarding torque, angular momentum, rotational kinetic energy, linear kinetic energy, etc. etc. See, already in translation motion, we discussed about Newton's laws. So, Newton's laws, formulas in translation motion. What is the formula? F is equal to m into a. This is Newton's law formula in translation, linear motion. Same formula will be changing in rotational motion. F బదులు tau, m బదులు I, a బదులు alpha. Same formula in rotational motion. In rotational motion, the Newton's laws formula goes like this. In the place of force, torque formula, tau. Okay, in the place of m, I, moment of inertia. In the place of a, alpha, angular acceleration. Therefore, Newton's law can be also written as torque is equal to I alpha. Okay, so this is the formula for Newton's law in rotational motion. Ante kakunda, you have to make one point here. In rotational motion, some equations are also changing. Like in kinematics, I have given so many equations. V is equal to U plus AT. V square minus U square is equal to 2AS. S is equal to UT plus half AT square. These are in linear motion. These equations are rotational motion. First one, omega 2 is equal to omega 1 plus alpha t, where omega 1 is angular velocity initial, angular velocity final. T time alpha is angular acceleration. What is alpha? Rate of change of angular velocity. Rate of change of angular velocity. And what is angular velocity? Rate of angular displacement. d theta by dt, radian per second units. So d omega by dt అంటే అర్థం ఏంటి? దీనికి డెరివేటివ్ అంటే see d by dt of omega అంటే d theta by dt. So this is what? Alpha. So units ఏమవుతుంది దీనికి? Radians per second. So radian per second square. In linear direction, what is the units? Meter per second square. Okay na? అలాగే displacement ఏంటి? Rate of displacement. మామూలుగా మీకు velocity unit ఏంటి? Velocity ఏంటి? Rate of displacement, linear motion లో meter per second. So ఇక్కడ angular velocity ఏంటి? Radian per second. So radian per second. So radian per second square is the unit for alpha, angular acceleration. అలాగే సెకండ్ ఈక్వేషన్ ఏమవుతుంది? V square అంటే omega 2 square minus omega 1 square is equal to 2 alpha theta. ఇక్కడ theta is angular displacement. And lastly, yes, that is theta is equal to ut, omega t plus 1 by 2 alpha t square. So these are the equations when the body is in rotational motion in terms of linear equations. ఈ v బదులు omega వచ్చేస్తుంది మనకి, angular velocity. Alpha, angular acceleration. Displacement s బదులు theta వస్తుంది, angular displacement. Please note down. All these are very, very important in doing numerical problems, please. Right. Now, in rotational motion, one more point you have to make in mind. That is, when net torque is zero, what happens? Angular momentum. What is angular momentum? L is equal to I omega. మామూలుగా యాంగులర్ మొమెంటం ఏంటి మీకు లీనియర్ మోషన్లో ఎంవిఆర్, దట్ ఈస్ మొమెంటం ఇంటూ రేడియస్ వెక్టర్. సో ఎల్ ఈజ్ ఈక్వల్ టు ఎం, వి అంటే ఏంటి ఆర్ ఒమేగా. సో ఆర్ ఒమేగా ఇంటూ ఆర్, వాట్ హ్యాపెన్స్ ఎంఆర్ స్క్వేర్ ఒమేగా. వాట్ ఈజ్ ఎంఆర్ స్క్వేర్? ఐ, మొమెంట్ ఆఫ్ ఇనర్షియా. సో ఇన్ టర్మ్స్ ఆఫ్ మొమెంట్ ఆఫ్ ఇనర్షియా ఏమవుతుంది? ఎంఆర్ స్క్వేర్ అంటే ఐ ఇంటూ ఒమేగా. అంటే వెన్ నెట్ టార్క్ ఈజ్ జీరో, when net torque is, that means where there is no rotation, resultant torque సున్నా అయినప్పుడు L remains constant. L is equal to constant and I omega is equal to constant. అప్పుడు ఏమవుతుంది? I1 omega 1 is equal to I2 omega 2. These relations are very very important in solving numerical problems. When net torque is zero, rotation is not there. For example, when there is no rotation, torque zero అంటే అర్థం ఏంటండి? there is no rotation. Clockwise కానీ యాంటీ క్లాక్ రొటేషన్ అంటే ఈక్విలిబ్రియం ఉంది. సిస్టమ్ ఈజ్ అన్ ఈక్విలిబ్రియం, రెస్ట్ పొజిషన్. సో దెన్ వాట్ హ్యాపెన్స్? L is equal to I omega. So then I1 omega 1 is equal to I2 omega 2. So these formulas are very 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 important. So torque we can also define in this way. What is torque? టార్క్ అంటే ఏంటి మనకి? d by dt of L. This is also vector. Torque can be also defined as rate of angular momentum. సో అప్పుడు ఏమవుతుంది? టార్క్ is equal to d by dt. What is L? I omega. So torque is equal to, if I take I outside constant, then what happens? d omega by dt. But just now I told you what is rate of change of angular velocity? Angular acceleration. Therefore torque is equal to I into alpha. Torque units మామూలే, న్యూటన్ మీటర్ in linear motion. Okay? So I, moment of inertia units, kg meter. తెలుసు కదా యూనిట్? moment of inertia kg meter square. Mass into square of the distance, kg meter square. Alpha తెలుసు కదా యూనిట్, just now I told you, radian per second square. Okay na? So like this you can write the units for this one and you can apply in various cases while doing numerical problems. And last one more I left over, that also will complete. When body is in linear and rotational, and what is the kinetic energy formula? Suppose when the body లీనియర్ మోషన్లో ఉంది ప్లస్ రొటేట్ అవుతుంది, రొటేషనల్. దెన్ వాట్ హ్యాపెన్స్? వాట్ ఇస్ ది కైనెటిక్ ఎనర్జీ ఫార్ములా? హాఫ్ ఎంవి స్క్వేర్ లీనియర్ మోషన్లో కైనెటిక్ ఎనర్జీ ప్లస్ రొటేషన్లో హాఫ్ ఐ ఒమేగా స్క్వేర్. తెలిసేది ఎలా వచ్చిందో చూడండి ఒకసారి. వాట్ ఈస్ హాఫ్ ఎంవి స్క్వేర్ ఫార్ములా? half into m. What is v? R omega. So r omega whole square. ఇప్పుడు ఎంత అవుతుంది? 1 by 2 into m into r square omega square. But what is mr square? Moment of inertia. Therefore I can write as half I omega square. So kinetic energy formula in terms of rotational kinetic energy ఏంటి? half I omega square. సో ఒక బాడీ లీనియర్ మోషన్ ఉన్నప్పుడు లీనియర్ కైనెటిక్ ఎనర్జీ ఉంటుంది half mv square, అలాగే రొటేషనల్ కైనెటిక్ ఎనర్జీ ఉంటుంది half I omega square. This is very very again important in numericals. When body is going in linear motion, it will have linear kinetic energy and also rotational kinetic energy, half I omega. This is moment of inertia, this is angular velocity. Clear? Okay. So these are the things you have to learn in this rotational motion topic, and I think this is the end of this chapter. In next chapter again we will be meeting in oscillations. Okay, till then, goodbye.